This conference will now be recorded.
Hello everyone, good morning and good evening. Hello, am I audible? Good morning. Okay. So first, whatever was left yesterday, I have completed it. So let's see that, and then we will start cloud computing. So I have one Tomcat, rabbitmq, MySQL, nginx, and memcache. So yesterday I did set up MySQL and a Tomcat. Tomcat was not coming up because the latest version of Tomcat, it's taking a very long time to bring up the application, but it's coming up. Okay, so you have to wait a little bit patiently. Whatever we did for Tomcat, that was it. RabbitMQ setup I was showing you. So RabbitMQ, so we have few dependency, socat, erlang, installed to these two packages. Then with wget we downloaded the I downloaded the RPM, added the key, and installed RabbitMQ server. There are so many places here, yum update, you don't need to do this, you can ignore this, and start RabbitMQ service. Add this configuration to this file. This is echo is going to print this message, and that's an output redirection. It's going to put all that content into that file. Add the user in rabbitmq, username test, and its password is also test. Set the user test with tag administrator, restart rabbitmq, and that's it, done. Here I have shown you the step of installing Tomcat directly through yum install, which will give you the older version of Tomcat. But we have downloaded directly Tomcat from its website, extracted it. That gave us the latest version. But you can go in any version, both will work. Nginx configuration. So let me start with nginx configuration. Wait. Yeah, before nginx, memcache. I told you memcache very simple. You just have to install memcache. You have to set up EPL release repository, install memcache, start the service, enable status, and run this command, which will run memcache on port 11211. Okay. Once that is done, last part is nginx. So did you follow the document? Did you do it? Okay, Virendra. Good. Half. All right. At least better than nothing. Only 2 people, that's it. Come on, all this hard work for what? Okay, so it's going to be apt update, and at this package apt install nginx. Once you install nginx, etc nginx, there will be these 2 directories, sites-available and sites-enabled. In this directory you create the configuration file, and when you create a link in this file that points, okay, you have to create configuration here. So this is the configuration file for the default nginx website that comes with the system. So we will disable that. So in sites-enabled directory, we have to create a link. When you create a link, that will point to your configuration file, which is in sites-available. So I have created here link Wipro app that is pointing to the configuration file. This one, okay, check the path. So now this site has become available, Wipro app. In this we have this configuration where we have the server detail, upstream server detail, Tomcat server IP and its port. If you have multiple, you can give there multiple like that. Whatever IP of the second Tomcat is, port 8080 or however you have. Right now we just have one, so we'll have it one. Listen on port 80. So that's going to be the front end port. Now here nginx is acting like a load balancer, so it gets the request, it will just forward the request to Tomcat. It's not doing anything else. Once that is done, you have to restart the service. So here are the steps. You remove the default website, you create new configuration file in sites-available, you put all the data, make sure you replace this with Tomcat IP. Okay, then create the link, soft link, then start the nginx or restart and enable nginx, and that would be it. So now what's the Tomcat IP? Tomcat now can be accessed directly without nginx also. Okay, so that's the IP of Tomcat server, colon 8080, and you will get the web page, login page. So I'm directly accessing Tomcat, but I'm using nginx as a load balancer, so I'll access nginx. Like here I have to give port 8080, here I don't have to give any port because the default port for nginx is port 80. It's running on port 80 and that's the default port which browser will try. So you don't even need to mention the port. You just give the IP, and again it has forwarded the request to Tomcat. So you're seeing this web page from the Tomcat. Now there is a user, if you have set up correctly, right, source code vp-rem branch, you would be able to log in with this user admin underscore vp. Its password is also same. Okay, this detail is coming, this user detail is coming from the MySQL database. The schema that we have deployed in MySQL, the user details are in that. So if this is coming up, then MySQL is also checked, connected to MySQL. Now we come back to Tomcat, but there's memcache, there's rabbitmq, other two services also, and we have a test for that also to check whether they are connected or not. So take a note of the file. So in Tomcat home directory, now this is Tomcat home directory. Okay, this is where I have deployed Tomcat. So that's Tomcat home directory. In that web apps, we will deploy our application. So here we have deployed it with the name root. So in our application, web.inf classes. Okay, take a note of this path. When you deploy the application in this path, we have the file application.properties file. Okay, Tomcat home, wherever you have Tomcat installed, in web apps, in our application directory, web-inf classes, because you need to edit this file a lot of times throughout the course. Okay, so take a note of this one. In that we have the file application.properties. Here I have told you we mentioned the database detail, so that's the MySQL DB IP, that's the username, and that's the password. And when we log in, it will use this database detail to fetch the DB detail. Okay, then memcache, also I've put the memcache IP, only the first memcache. We can have multiple memcache also, but since we're using one, that's the memcache IP. So if you make any changes to this file, you have to restart the Tomcat service. Okay, you have to shutdown.sh script, and then restart startup.sh. If you're directly installed Tomcat through yum, then you can use systemctl command. If you installed it the way I did it, downloading the package, then shutdown.sh and startup.sh. You have to use those script to start and stop. So I've add the memcache details there, and I have added the rabbitmq IP. Okay, port I have not changed because the same port that we are using, default ports. Okay, for rabbitmq we added the username and the password also, the user that we created in rabbitmq. So that all good. I made the changes, I restarted Tomcat. Then let's test it. So first let's test rabbitmq. If you click on rabbitmq, it should go and connect rabbitmq service. Okay, if you see this message, that means rabbitmq is connected. Okay, it's sending queues through rabbitmq. You'll see this message. If it's not connected, it will take a very long time, then this will fail. That means rabbitmq is not connected. So this is a test purposefully was created for you people to check, so you can see whether their services really connected together or not. Then for memcache, It's a database cache. So in the database, we have user details. So we have created a button here, all users. You can click on this. It will show list of all the users. This is coming from the database. So let's click on some user, Kiran Kumar. Okay. If I click on this level number. Okay. First it is showing data is from DB. So it's fetching, it has fetched the database from the database. Sorry. It has run an SQL query, fetched the details from the database, and then it has inserted in cache. Now it's in cache. If I go back, now the data is in cache. If I click on this again, it should show me from cache. You see, data is from the cache, and it will be much faster. That means memcache is also connected. So you have a successful deployment. Okay, coming from the database. So this message is purposefully put for the test. Okay, this is only for the test purpose. All right. So only two people have set it up. Half. Not even two, 1.5 people have set it up. Nobody else. Oh, there are like, I don't know, 17 people, 16, 17 people in the class. Seriously? That's your seriousness? Man. 2.5. Okay. With this seriousness, people, you really won't be learning much in DevOps. Trust me. If you don't have the seriousness, there's so much more to be, you have to learn. This is just the beginning. We have just, you can say till today, we made our base strong. That was just the base. The actual learning will start from today. If your base is poor, then God help you. Okay, yeah. Get a dongle, do something. All right, Lakshman. Because that shouldn't be the reason. Now, trust me, no, I don't feel good. When I'm showing you so many things and you people don't practice, it's like all for nothing. And it's not only just about money, people. I want you to really learn. And you go out there, you tell them that how did you learn? Who did you learn from? That will be my great victory. And not just this. All right, the world is changing very fast. People keep asking me question. They already learned so many things and they're still asking me question. Okay, what else Imran now? What we have to do? Which area do we move? And these are very basics if you're not trying. Okay. Anyways, I have to do what I have to do. What can I do? But I don't feel good really about this. Okay, that you should know. Let's start cloud computing, shall we? Shall we start cloud computing? Okay. So that desperately everyone is waiting for. Okay, so let's start from the very start when the cloud started. Now, today is the time where you can't really live without cloud computing. There is a reason why. No, the DevOps course here started with just DevOps technologies. I was not teaching cloud, but then I started including cloud slowly. Few services of cloud. Then I started adding more services, more, and now the course has become cloud computing, AWS cloud plus DevOps. Here itself, there was so much of evolution. It's because, see, cloud computing is not DevOps, or DevOps is not cloud computing. You can say we leverage cloud computing a lot. Being DevOps, you'll use a lot of cloud computing, and that's the reason you should be learning cloud computing. You would be automating the steps in cloud computing, and there are so many benefits that cloud gives us that we'll see. And these are some reason why you should be learning cloud computing, being DevOps engineer. uh, there was a time people used to get job just having cloud computing knowledge, but today is no, nowadays it's just not the day. People are not hiring separate cloud admins, or people who only know AWS cloud or Azure cloud, because cloud computing is very easy, to be frank with you. Okay, it's the easiest thing that we would be doing in this course, in this entire course. But being said that, the concepts are a little difficult if you don't have the background. Okay, if you have the background, what is VMs, virtualization, operating system, this, that, if you know the concepts, then it's easy. Otherwise, it's anyways painful. So why is cloud like everywhere? So first, let's understand what's cloud computing. I have told you about virtualization hypervisor, right? So for production, what type of hypervisor we use? For production environment, what type hypervisor? Type 1. Good. Very good. Some example. Can you give me some example? Come on. ESXi, okay. Hyper-V, right? AIX, HIVO, right? Microsoft has Zen. Very good. So these are some type 1 hypervisors. All right, now I'll tell you a little story. So most part of the story is true. So Amazon books, right? Previously, Amazon has only, or you can say that's the main business of Amazon was Amazon books. Used to sell books online, and still it's a very big business for Amazon. Uh, and it has a lot of customers around the world who used to purchase books. And we have like nice web portal which user will access through their browsers or through their app, purchase books. Lots of user. And Amazon's all the infrastructure was running on virtual machine, so most part of it was running virtual machine, and it was virtualized with hypervisor Zen hypervisor. And it has a data center, a huge data center, entire data center. Most part of the data center was virtualized. That means type 1 hypervisor was installed on most of the computer. So to manage such big infrastructure, there was a virtualization team. Now, Amazon being a huge company, there are thousands of employees, and these employees always need virtual machines for purposes like development, system administration, operations work, R&D. And there was a virtualization team that was managing this, giving virtual machine, set up virtual machine, give it to some certain user. Some people need extra RAM, some people need extra CPU. So the elasticity of virtual machine, add more data, remove, such kind of thing, the virtualization team generally was doing a normal day-to-day job. But being such a big company, a lot of employees, there was too much burden on virtualization team. So some smart people thought there, why don't we make this a self-help portal for them? Like like people create ticket, okay, to the virtualization team, that set up me this, and they'll look at the ticket and then they'll do it. Now think about it. They have a web portal where they can fill in all the details what all they need. Like, I need a virtual machine of this size, this is the hard disk size, this is the CPU. They say submit, and it will create a virtual machine for them and give the access. As long as they want to use, they can use. If they don't want, they can also delete it from there itself. So you're giving some control to the users so they can manage their virtual machines in the data center through a web portal. So they can open it from your browser web portal, like set up a web application like vprofile that we have just set up. Okay, like that web application. From there you can manage your data center. You can, it's a self-service. So that was a great idea. They did it. So they enabled API based access on their data center. Okay, I want you everyone to do one thing. After the class, go and check what are API. Okay, if you don't know APIs, now some URLs. Okay, it can be programmed. So they created API based uh, data center. Their hypervisor can be accessed through API, and if you have API, you can then set up a web page and access all that from the web page. You can hit the APIs from the web page, basically a web portal from where you can access the infrastructure. So that was a great success within the organization, and this was dawn of cloud computing. Okay, now NASA, everyone knows NASA was doing do some research. They all the time will do research. And I don't know if you know this, but when they are doing this space research, they need huge amount of data. The huge amount of data gets saved in their disks and all. Okay, petabytes of data in seconds. All right, it's huge. Once I was watching this in Discovery Channel, I was really amazed to see how much data they're storing per seconds. So they ran out of space, they ran out of compute resource in their infrastructure. So they contacted Amazon, so if they can rent some space from their data center. And Amazon had this web portal, where you can access and you can store your data, or you can create virtual machine. So NASA and Amazon had contract, and NASA had accessed the data center of AWS, sorry, Amazon, only Amazon back then. And then they were paying them per hour basis. And if I store this much data, I'll pay you this much money. So Amazon, after doing this contract, found that there's a good business. They got a lot of money because of renting some space on their data center through their web portal. And they thought, why not we make this as a business? Now, this was dawn of public cloud computing. Okay, previously what Amazon did internally was private cloud computing. When they gave access to NASA, that was public cloud computing, giving it to the public. And then they have set up the complete business AWS Amazon Web Services, from where anybody in the world can set up an account and start creating virtual machines, storing their data on their data center, on Amazon's data center. Okay, that's what is AWS, Amazon Web Services, the pioneer in cloud computing. Then so many services came in AWS, and then other competitor also came now, Azure, Google Cloud, right? So now you see cloud is everywhere. There's a recent statistics, more than 90% of the IT organization are using cloud computing. That means wherever you go, there are chances, 90% chances that there will be cloud computing. Okay, so cloud is a metaphor for a network, internet actually. And computing, I already told you, the compute resource, RAM, CPU, network, these are compute resources. So if you are accessing a compute resource over the internet, or over the intranet, or over the network, then that's cloud computing, and you pay per hour basis. Now payment is for the public clouds, right? We have private clouds also, where internal organization use their own cloud, and of course their people won't be paying to the organization, right, for that. But if you're accessing compute service over the internet, it's cloud computing. So computing has just become like a utility, like electricity. You consume electricity and you pay per unit. When you want electricity, you don't create your own powerhouse. At the max you can have your generators, right? But but that's not feasible to manage for you. It's too much huge cost, and you will probably not be using that much electricity also, right? So what we do, we take the electricity from whatever electricity board is there, and we pay per unit. Similarly, cloud computing, we don't set up our own data center, we take it from someone else and we pay them per hour. Okay, so that's cloud computing. API, technical definition is API based access to the data center, to the infrastructure. Okay, API based. And check that, what is it? All right, so everyone clear about what cloud computing is? Virtualized data center and API based access. Simple. Now, I was just yesterday talking to one of my friend who has, distance friend, you can say, who has set up their own startup organization. And I just asked them that, who is managing your infrastructure then? So they're like, we just have one project, and for the infrastructure, we are using AWS, and that's all. We don't need anyone. Okay, it's like you're gonna get good business. Like, the confidence was like this, right? In the startup, in all times, if someone is going to start an organization, they need huge amount of capital to set up the infrastructure. But now it's so easy. If you have your card, you can just open your account and you can start creating virtual machines, start storing the data. As simple as that. So you don't need to invest too much of money, and you easily, like developers and other people can manage it without, huge amount of application, infrastructure knowledge. And you pay as you go. If you're getting the money, if you're growing, infrastructure is growing, you pay money. If you are not getting, you simply shut it down, delete, and that's all. It's true elastic in nature. That's one of the biggest benefit of cloud computing. I have a virtual machine with so and so size, right? Like say 50 GB of RAM, 4 CPU. Not enough. Anytime I can extend it. Okay, add extra RAM, extra CPU. Right? I can scale up and scale down. If it's too much, investing a lot of money, then scale down. Right? So the headache of managing infrastructure is gone because of cloud computing. So I can now focus more on my product. So my friend is more focusing, of course, on the product development, the product that they're developing, rather than wasting their time in the infrastructure. If they have their own data center, then they have to do a lot of things. Somebody should be there to be managing it. Okay, it's too much cost involved in data centers and all. So you can focus on your development, product engineering part, rather than, putting your brains and times and effort in your data centers. All right, so these are some important benefits. We'll come to this graph later. So the cloud computing gives you other benefits also, like, as pay as you go, right? So some example, like let's say you're using 10 virtual machines, and that is costing you x amount of money. Okay, every day x amount of money it is costing you. But if you shut them down, if you're not using them, then the meter will stop. The x amount of money that you are paying per day, that bill won't be applied. Okay, so for example, a normal stock exchange or Wall Street example, you have a lot of computers that will do computing, a lot of data science and stuff like that. But let's say Saturday Sunday, you don't need to do all of that because the market is down. So Saturday Sunday, you can shut down your computers, you shut down your VMs on the cloud, and there won't be any charge. Okay, storage is a different charge. All right, but for the compute resource, CPU, RAM, you won't be charged. All right, so you can have such kind of automated infrastructure also. Automated infrastructure. So you see here, blue line is your is an example of your physical infrastructure. You purchase, let's say you have like 50 computers you have purchased with some storage, right? And this red line is your actual demand. So initially you took that much, your demand started with very less, then it grew, the demand grew, more users are coming in, then because of some reason the demand is reduced, right? And or whatever expenditure we have put on the computers and data center, right? But that is still not met, so that much is all loss. But your demand is now growing, that, so you add more infrastructure. Let's say you have added 50 more computers. Okay, so that's 50 more computers, but your actual demand, then again, it we thought the business is going to grow, but because of some reason it went down, right? From here to here, that much money is, you have lost that much money. Okay, because you're not using your resource, and these are very expensive computers, by the way, not just laptops I'm talking about. Okay, use physical computers which is in the data centers, Dell PowerEdge and stuff like that. Then your demand again started growing, but because you're so upset that, I add more and, it will not grow, so you don't add the extra amount of computers. So what will happen if the demand suddenly is growing? you're not able to scale up with the time. By the time you scale up, your site, your applications will be down because your demand is too high, your infrastructure is not supporting it, right? So physical infrastructure is not elastic in nature. It takes time to add more computers in your data centers to bring them up, right? It takes a lot of money. But if you have automated hardware, automated virtualized hardware, as your demand grows, it will add instances, right? If the demand is not there, from 50, let's say you don't need now, 25 will be deleted. Then the demand is increasing, okay, I'll add more 25, okay, I'll need 30 now, I add more 30 computers. Then demand is not required, it's not required, then delete that many computers. All right, you see, this the benefit of automated virtualized environment is you save lot of money, lots and lots of money, trust me. And we are going to see this through auto scaling. Okay, there is a concept called auto scaling in AWS cloud, where the hardware will actually automatically scale up and scale down as per the demand. Okay, right. So so AWS came into the market with the cloud computing concept, and then there are so many companies which started using it. It was really a jaw-dropping experience. I'm accessing through my browser someone else's data center and just creating their virtual machine. I'm storing huge amount of data, terabytes of petabytes of data there. So many company started using AWS cloud computing, right? Started with NASA, then now there are so many companies. Okay, this you can't fill that in the slide also. But then there are so many things that other things like licensing of the operating system, licensing of the software. uh, so one thing is that you can bring your own license, BYOL they say. Okay, but that's not required in Amazon. The Amazon has partnered with so many other technology vendors, providers, like Oracle, Red Hat. So you can even get the licensing from AWS, and licensing will also be hourly basis. Okay, and that's great. You don't need to purchase an yearly license of some product if you're not sure whether you're going to use it for a year or not, right? So you can pay like hourly basis. You can have a Red Hat Enterprise Linux operating system, you can have Microsoft Server Windows operating system, you can have Oracle database, and you can pay the licensing of it hourly basis. AWS has partnered with so many vendors. Okay, now there is some uh, fight going on between AWS and Oracle. Not exactly fight, but some licensing issue. Probably Oracle will move its customer to its own cloud. Oracle has its own cloud now. Okay, so because of so many people wanted to use cloud computing, so AWS, Amazon Web Services, has initially its data center in US, then it expanded. It has created its data center in European region, then Asia Pacific, okay, Asian regions. It's creating now in South America. It's in India also now. So now uh, AWS has its data center across the world. Okay, so many part of the country, world. So let's log in. So everyone set up their free tier account. Okay, VJ, my man, will do it, huh? Virendra also. Okay. All right. So you click on login, and you will log in with your username and password. This is called as root login. Okay, root user login with your email address and password. Okay. Click on this EC2 to check whether your services are enabled or not. Account gets created, but sometimes the account doesn't get activated or enabled. So if you see this screen, it's activated. If you see some errors, that means there is some verification problem. So your phone or your email or your card, either of these three things is not verified, so you will get errors. Okay, don't do anything as long as I don't tell you. Load balancer is there. Oh yeah. Okay. Yes. Okay. So when you come to the main page, come on, take me to the main page. Yes. This is the main page. Here you will see all the AWS services. There are lot of services, and it just keep growing every day. But don't panic. They have services like machine learning. There are separate services for development. For media services, there are separate services. Like if you're working in media providers and all, you may use these services. For mobile development, there are separate services. For storage, database, our interest is mostly in compute, storage, database, and later you can migration and transfer, migrating your physical infrastructure to AWS cloud. These are the services that can help you with. This is of our interest. Networking, development tools is our interest. Robotics, not yet. Blockchain, satellite. Okay, that's something new. Communicate with satellites, really? And these people are crazy, man. Just keep adding services. God knows. IoT, see, IoT section is separate. Then game development, analytics. You can, if you are in an analysis and all, then you can use these services. Security will use one or two service. There's so many security related services because people are really paranoid to put their infrastructure on the cloud. They think that they're putting it on the internet. Okay, but security is all in our hand. Okay, I will explain you that. So that many services, so many services, but don't worry, you have to focus on the services that you use. Being a DevOps, what all services are required, that we'll focus on. So we'll be focusing on sysops and DevOps. Okay, two areas, sysops and DevOps. If you want to check what it is, just Google it. Okay, AWS sysops and AWS DevOps. We'll be focusing on those services. Now here you have your account details, your billing dashboard. You can keep checking your bills. As of now, do not use any service if you don't know. Don't click here and there. If you get any extra bill, then don't tell me. Okay, and in any case, if you get by mistake any extra bill or anything, don't worry, it can get worked out. You can contact AWS support. You tell them that I'm learning and you did it this by mistake, and they will you say, they'll tell you to delete your account. That's all. Okay, don't just get vanished. Clients are still worried about PN data to put on the cloud. Is that true? Yeah, everybody is worried. We will talk about that. It's actually the worry is coming from a very different area. I'll explain you that those concepts. So keep checking your billing dashboard. um, all right, your account details you can check. So these are the data centers, you can say regions, we call it as in AWS. So the AWS has presence in these many places. So you have to select any one. All right, all regions are separate from the other. In any region is separate from all the other regions. They are separate entities and can be accessed from a single place, but there is no direct cabled connection between these regions. Only internet based access is available. Okay, so if you have to select your own region, what you want, how to select, on which one to select, that I'll explain you later. You see, North Virginia and US, there are 4 regions. Okay, as of now, you can say 4 data centers. Then in Mumbai, there is one. Seoul, Korea, Singapore, Sydney, Tokyo, Canada. So you can go variety of places from here. See, you can go to Canada in just with one click. No visa required. Directly in the Canada data center, right? So now whatever services I'm going to use, everything will be created or set up on the in that particular region. Like here Canada, then Europe we have so many. This one is recently added, Paris. Okay, Stockholm, this one is also added. All right, Mumbai was added, I think, last year, something last year. So they keep growing, and they'll keep, they'll add more and more region. I'm sure about that. I have seen this crazy development of AWS from the time I'm, in my started using AWS cloud or watching it, you can say. I've seen their development, and they're like huge, huge now. So it's presence everywhere, every region. Let's go to North Virginia. So actually, this region is just a label and not actual data centers. You click on EC2 service, EC2 dashboard. Now everyone try this today, okay? They select multiple regions, go to EC2, click on EC2 dashboard, and here you can see zones, availability zones. Now, these are actual data centers, okay? To the region, there will be a code US East 1, North Virginia. Okay, that's the code name for it, US East 1 region code. And in that region, you'll have multiple zones, US East 1A, 1B, 1C. Now, these are actual data centers, physical data centers, and all these zones in a region will be physically connected with each other. Okay, so you can have your let's say we know virtual machine for now, right? So you can have like you have like 8 virtual machines, so you can put 4 here and 4 here for high availability. Okay, if one zone goes down, your other zone will be still up and running. Okay, you can distribute your infrastructure, and that we will see through VPC. By default, we don't select our zones, we just let AWS select the zone for us. When we go in VPC, when we talk about network high availability, that time we will be leveraging these concepts. As of now, just understand every region will have minimum 2 zones, minimum. Okay, and they are physically connected, so you can have computers here and here, you can have storage here and here, and there will be a normal connection. There won't be any lag, all right, in communication, right? But across a region is a different thing, that you have to do it through the internet, right? But this is internal communication. Like that, if you go to Ohio, let's check different regions. So Ohio has 3 zones, 2A, 2B, 2C, and you may be seeing something else. Okay, if you're in US or somewhere else, you may seeing instead of 2A, you may seeing 2D, 2E, 2F, you may see that also. Okay, but Ohio is giving me 3 zones, that's for sure. For everyone there will be 3 zones. Okay, Mumbai, I think there's only 2 zones, minimum 2 will be there. Okay, and that's an interview question also. 2 zones. Okay, these zones will be actually cluster of data centers, and I'm sure everyone knows what's data centers. Okay, so availability zones are clusters of data centers. All right, they're isolated from failure. Availability zone goes down, it won't affect the other availability zone. And thus availability zone goes down, well, in AWS history it went down, okay, few times. All right, it's very rare, but anyways, you have to take care of high availability. You cannot predict anything that it's going to be 100% up. All right, okay, so it's very important slide. So people keep asking me this question, hey, this is some new service from AWS, uh, then we have to learn this service also now. They're using it in my organization, and I have no idea about this service. Right, I hear this a lot. See, you have to understand the cloud computing business models. Okay, there are 3 main business models in cloud computing. infrastructure as a service, platform as a service, software as a service. Whenever you see a service, you see its nature, you should be able to understand it is which kind of business model, SaaS, PaaS, or IaaS. If you can understand that, if you can, segregate that, then you will know how much work is required, or is really required or not from your side, or is it like just developer or the tester, or some person who can take care of it. Okay, so if you can do that, then you can talk about giving solutions and so many things. You will know how much you need to automate, how much work is required if you see a service nature, if you read the documentation. So I'm going to explain you. If you have a question, you can ask me. So infrastructure as a service. So far, I've been talking about virtual machine and normal storage. Okay, virtual machine that comes into infrastructure as a service cloud model. Now, in this case, I told you the data center. Now we'll go back to our AWS story, right? They virtualize their data center, right? So they have their own network, storage, server, virtualization. They rent a virtualized data center. Okay. Now what we do, we open the browser, we click on EC2, and we, let's say, create virtual machine. So when we create virtual machine, we have to manage that virtual machine. Okay, the operating system in that virtual machine, whatever softwares are running in that, whatever services are running there, like let's say MySQL database, then it's data, and whatever application we are hosting like vprofile and all these things we have to manage. Vendor is going to give you the virtualized infrastructure. On top of that, whatever you do, it's your work, it's your headache, you have to manage it. So if I create a virtual machine on AWS cloud through EC2 instance, I have to manage it from its operating system to entire application, everything I have to do, deal with it. Okay, such kind of services, infrastructure as a service. So you set up your own infrastructure, it's virtualized, but it's still an infrastructure. Now you have VMs, then there will be load balancers, then there will be network, then there'll be storage, so many things. You create the entire infrastructure like what we did yesterday and today with vprofile. Okay, that is infrastructure as a service. Okay, easy to understand because so far we have been doing it, but now cloud gives you much more flexibility. So that's infrastructure as a service. Okay, EC2 instance, virtual machine, I can just say launch instance, I can select the operating system, I fill few details, and boom, instance will be launched. But then I have to manage it. Then I have to set up a load balancer for it, storage for it, volumes. Okay, it's load balancer, it's network, it's IP. All this I have to manage. All right. So if I'm setting, let's say, MySQL database, so I'll create a EC2 instance. I will log into it. I will install MySQL, whatever we did previously, and then I maintain and manage it. Okay, but now MySQL database service, there are so many things that comes with the database. It's one thing, it's the most critical thing in your infrastructure. You have to always make sure that it's always up and running, it's fast, and if there is any failure, then you should be able to roll back. That means you have to take regular backups also. So all this headache comes with the database, so that's why you have database admins who can manage all these things for you. But AWS gives you a service, RDS, relational database service. Now this service is platform as a service, PaaS service. So it gives you directly the platform. All right, the database platform. You select what platform do you want? MySQL, Oracle, PostgreSQL. Okay, and you just select the platform directly. All right, Oracle you want, okay, fine. Then you go next, you do some form filling. It's just like form filling. You just do form filling and it will set up a database instance for you. Now in there you don't have the operating system access and all. You just get the database, you just start storing your data there, that's all. But you still have the control. You can increase its size, decrease its size, that all you can do. Okay, you can set up the backup times and all, but backups, everything will be automatic. So you directly get the platform. You have little bit control, not too much. The OS, the middleware, runtime, everything is managed by the vendor. You just, just put your data and start running it. That's all right. And you still have the control on the data. You have the control on its compute size and all. Okay, these kind of services are called as platform as a service. You just seen an example, RDS. Like that, there are many PaaS services. The world is of now PaaS services mostly, right? So in PaaS services, we have very less work. There is work, of course, because we still have the control, but not too much. Most of the thing is managed by the vendor, in our case AWS. Then comes SaaS service, right? This is where it gets scary and people say, the world is coming next where people are going to lose a lot of jobs and this and that. Automation is killing a lot of jobs. It's because of this SaaS services actually. Okay, now, all right, we have set up memcache service, right? And that's the reason why I set up the application first. We have set up memcache service, or let's say rabbitmq service we have set up, right? So to set up a rabbitmq service, if I'm doing it on cloud, I will create EC2 instance and set up all those things, and then I will start using rabbitmq service, and then I have to maintain and manage it. But what if I can go to a service, AWS provides you SaaS services like SQS. It's a queuing service. What you do, really just subscribe it, that's all. Okay, get started now and it will start. You can just take the URL and you can start sending the queues. You don't need to set up the infrastructure, you don't need to control its size and all, nothing. Just subscribe and start using it, that's all. And here you don't need any operations work, nothing. The person who knows about queuing can do anything with it. Okay, similarly for storage. Okay, you want to store the data, right? Go to S3, just like Google Drive. Okay, in Google Drive we create folder and we start putting the data. Here we create bucket, we say create bucket, we create it, right? And then start storing the data, upload, that's all. Okay, and this will be mostly done through command lines. We'll see how to do this data storing through command line and all. It's a very popular service. This is a first AWS service, S3. So this is SaaS service, software as a service. And nowadays, all cloud computing vendors are focusing more on PaaS and SaaS service, because infrastructure we already know, VMs and stuff like that. It's not going to grow more than that. Okay, but think about backend services, right? Just a moment. Okay, so our infrastructure. So now if I'm going to do all this on the AWS cloud, first I'll think I'll create EC2 instances for all of this service, and then I'll be start using it, right? But MySQL, you can use RDS. Okay, and all the system will start storing some data, logs and all that can go to the S3 bucket. Instead of nginx, I can replace that with the load balancer, elastic load balancer. That's from AWS. Instead of rabbitmq EC2 instance, I can use SQS service. Instead of memcache EC2 instance or VM, I can use the memcache service from AWS. This AWS memcache service. Elasticsearch, there is an AWS Elasticsearch service. So there are so many services. MongoDB, there is, you can use it directly DynamoDB. So if you're going with PaaS and SaaS service, your complete infrastructure can change. You can just have this for EC2 instance, running this on EC2 instance, and all of the other services, different PaaS and SaaS services, not VMs. That will change your entire infrastructure, right? But people are still scared about giving the control to someone else. Okay, they'll be always scared, if they get the complete control, how will I control my data? What if they hacks it? What if they takes the data, sell the data, stuff like that. There are so many questions like that. Okay, so with all that questions, we'll use those questions as a cliffhanger for the tomorrow's class. Okay, we will tomorrow set up an account on our AWS. Users will secure our AWS account, and then we'll start using EC2 service. Okay, that's all for today. So you have things pending, please complete it. Set up the vprofile architecture, so it will be easy for me to train you on AWS cloud. Okay, these are the basics. All right, that is all today. Any questions? So all your cloud related question, if you have, how we're going to do this, that, all will be slowly answered. Okay, be patient and please practice, man. Please practice. Okay, then I will see you then tomorrow. All right, take care. Bye bye. Have a good day and night.